shared him the Google Meet.
Okay. Okay.
And one more, sir, I forgot his name. He also will join.
Okay.
What's the time there, ma'am? What's the
It's
time now?
it's about 10:25 p.m.
Okay.
Yeah, it's at night.
It's around midnight now.
Yes. Yeah. And are these mostly students that you have on the call?
Yeah.
Okay.
Most
And these are civil
and also
engineering?
the delegates, from
Okay.
the various
Okay.
institutes.
Okay.
So here we are offering MTech in structural engineering, water resources, and environmental engineering.
Okay. Okay.
The college is closed for the Christmas vacation.
Okay, so you did have classes even though the coronavirus.
No, it's an online only, but on 28th, the physical class sessions are starting now. That's for only for the final years. After that, pre-final years.
Okay. So you don't have geotech there?
No, nobody is afraid of corona.
Okay.
But we are maintaining the social distancing.
Okay. So and everybody puts mask and so on.
And then the sanitary precautions.
Okay. Yeah, my family is in Trivandrum, so.
Yeah.
Yeah.
I know that. So Jairaj sir is attending today for the second session.
Okay.
I told him about Madina.
Okay.
1 minute. Hello, madam. Dr. Saji Kumar, sir. He is an alumni of CET. Do you know him?
Yes, I do.
Sir? Saji, sir?
Hello?
Yeah.
I am 2 years senior to you, ma'am.
Okay.
I'm from 87 batch.
87, okay.
First entrance batch.
Okay. And you're teaching in Thrissur too?
Yeah,
Saji?
yeah.
Oh, okay.
I am here.
Okay.
For the last 30 years.
Okay.
He served us as a HOD of civil engineering.
Oh, okay.
1618, right, sir?
Yeah, 1618.
He's the senior most and mentor to us.
Okay.
Sir's wife is also teaching here.
Okay.
Yes.
last year, this time, I was actually in Trivandrum at this time. I had come for one of my nephew's wedding. But now, there's no travel.
I, my sister is also in US. She's in Arizona.
Oh, okay. Okay.
My twin sister.
Oh, okay. Oh, okay.
Nine. 2 more minutes to 9 a.m.
Oh.
A very good morning to one and all present here. Welcome you all to the third day of Civil Engineering and Architecture for Sustainable Infrastructure Development and Environment, Seaside 2020, jointly coordinated by the Department of Civil Engineering and School of Architecture, Government Engineering College, Thrissur, under the Biennial International Conference on Emerging Trends in Engineering, Science and Technology, ICE 2020. It is my and our pleasure to introduce you to the esteemed keynote speaker for the first session today, Dr. Beena Sukumaran. Dr. Beena is currently the Dean of the College of Engineering and Computing at Miami University in Ohio, United States since August 1st, 2020. Previously, she served as Vice President of Research at Rowan University in New Jersey, USA from 2018 to 2020. She was on the faculty in the Civil and Environmental Engineering Department at Rowan University since 1998. She worked at Amoco and Norwegian Geotechnical Institute on offshore foundations for deep water applications before joining Rowan University. She obtained her PhD degree in civil engineering from Purdue University in 1996. Her previous positions at Rowan was as President's Fellow for Diversity and Inclusion from 2017 to 2018. She served as Department Head of CEE for 7 years from 2010 to 2017. During this period, the department doubled the undergraduate student enrollment and grew it to a highly competitive and sought after program. In addition, she supported the development of a new undergraduate program in construction management, and the department inaugurated a new Center for Transportation Research, CREATES. She is a firm believer in service and experiential learning and has started a venture titled Engineering Innovators Without Borders, EIWB, in 2007 to develop devices that will improve the quality of life and provide entrepreneurial opportunities for the developing world. In 2016, she and her team was awarded the NSF Revolutionizing Engineering and Computer Science Department grant for $1.92 million, which is titled Revolutionizing Engineering Diversity. The research explores new strategies to recruit and retain a diverse engineering student body while creating an inclusive civil engineering curriculum. She will be speaking on geotechnical challenges posed by climate change. I'm extremely honored, ma'am, to welcome you as the keynote speaker to this conference. Welcome, ma'am.
Thank you, Shruti.
Thank you.
And thank you, Sina ma'am, for inviting me, and also thank you to all the organizers. So I'm not sure if I should say good morning because it's nighttime here. It's around 10:30 p.m. in the US. So I will actually start sharing some slides with you, if you don't mind, and I hope you can. I will do that shortly. Let me see if I can. Can you see the slide?
No, ma'am.
Okay.
Now it's coming.
Okay. So I'm here in Miami University, which is in Oxford, Ohio. So this is actually one of the Midwestern states in the United States. And I've been here only for a few months, and I actually serve as the Dean of the College of Engineering and Computing. And I'm very grateful that you've invited me. I wish I could have been there in person. I usually come to Kerala at least once or twice a year. In fact, last year, I think I came 5 times. But this year, with the pandemic and, coronavirus happening, travel is not encouraged by our campus. And as you know, if you've been following the news, case numbers in the United States is actually very high. So it wouldn't be safe for us to travel to India. So with that, let me start talking about, the geotechnical challenges. My area of specialization is in geotechnical engineering, and that's what I have taught and researched in for a long time. But I thought before I get started, because we have lots of students in the audience, I thought I'd give you a brief run through of Miami University itself. And we don't have a civil engineering program here, but we do have the other majors. So if you can tell your friends, especially those who are looking at graduate school, if they would be interested in coming to Miami University, we would love to have them. So just to give you an overview of the college itself, we do pride ourselves on being a top undergraduate program in the country. And we are also considered a public Ivy, meaning it's a public university, it's a government-funded university or a state university, but it's also considered as an original Ivy League school. And if you look at some of the programs that we have in the college, we pride ourselves on being very socially engaged engineers and computer scientists. And so we have this focus on humanitarian engineering. We have a Center for Assistive Technology. We also have students who work on the grand challenges, and think about better medicines and so on. We have also had a paper science program for a long time, since the 1960s. So it's actually one of the oldest paper science programs in the country. These are the 4 departments that we have in our college. We have a computer science and software engineering, which is actually our largest department, with about 800 students. Chemical, paper, and biomedical engineering, electrical and computer engineering, and mechanical and manufacturing engineering. These are the graduate programs that we have. In fact, our undergraduate students can do a BS plus a master's degree, so that option is available. We do have a Master of Science in Chemical and Biomedical, in Computer Science, in Electrical and Computer Engineering, and Mechanical Engineering. And we are just about to start actually an MS program in clinical engineering. So these are, as we start thinking about what might be the degrees of the future, and especially in light of what is going on with the pandemic, we thought it is important to have engineers who are trained to be able to function in a hospital setting, set up a hospital, procure complex equipment, maintain that equipment, train people to use that equipment, and so on. So that will be the Master of Science in Clinical Engineering. And just to give you some of our research areas that our faculty work in, we do have quite a few clusters of strength. Advanced communications and networks out of our electrical and computer science, artificial intelligence and machine learning, assistive technology. So we do work with the Center for Gerontology. So for older people with disabilities, how do we help them? Biomedical engineering and biotechnology, advanced materials, manufacturing, high performance computing. In fact, we have a group that's working on quantum computing at the moment, micro and nanotechnology, and then robotics, automation and control, and of course, sustainability and the environment. These are some of the areas that our faculty work in. So this is mostly our biomedical engineering group. They do some work on animals. So what you see here are rat bones that they're looking at. They do look at implants, sensors. They do some tissue engineering, as well as in this case, some ulcer prevention. So that is what is shown here on this slide. And then, I mentioned Miami University Center for Assistive Technology. So we do work with people with disabilities as well as older people. So in this case, we're looking at how does your gait affect your stability and so on. And they do some experiments along those lines as well as computational work. These are some of our research support. So we try to fund lots of our research through external support. Some of it is through federal government support or, central government, as in India. And then we also get some state support, and then lots of industries also sponsor our faculty research. So if you look at where we are, Miami University, if you look here, we are right here in Oxford, Ohio. So, and surrounding us, we do have lots of industries. This used to be a huge manufacturing hub. It used to be a steel manufacturing area, but now it has transitioned to more medical devices, steel. There's still some steel. There's car manufacturing. Lots of robotics. In fact, we just started a bachelor's program in robotics engineering as well.
Okay, ma'am.
So if you have any questions about our graduate program, Dr. Kumar Singh is our graduate director. You can reach out to him or send an email to that email that's shown here. So if you have friends who are looking at graduate school, who are in any one of these areas, please do encourage them to apply. So now I'll get started on, the topic of presentation here. And before I start, I wanted to talk to you briefly about some of the grand challenges for engineering. Of course, as civil engineers, we don't work in all these areas, but we do support it through infrastructure development. So some of the areas that are critical for civil engineers, or where civil engineers play a large role, is of course in clean water, in how we improve urban infrastructure, in even engineering tools of scientific discovery. If you look at lots of the climate change issues with carbon sequestration, solar energy, and so on. So this is something I like to keep in mind as we think about educating the next generation of engineers and civil engineers for that. So just to give you an overview of, what is going on with our planet, if you look at how, I guess, the temperatures on our planet have been increasing over the past few years, and you can see these are the carbon dioxide levels. And what you see here is a steep climb in the emissions of carbon dioxide, and this is from NASA. So you can see till the 50s, we were at a very stable rate, and then you see this huge climb in carbon dioxide emissions. And carbon dioxide being a greenhouse gas, it has caused our planet to warm up. And that is the reason that we see a lot more severe storms and so on. And that is something that you can see here on this slide here. The green here is, of course, geophysical events, which is not impacted by climate change. So these are like earthquakes, tsunamis, volcanic activities. That is just because of the planet shifting, right? The tectonic movements. But what you see here in this dark blue are meteorological events. So these are weather-related events. And then the slightly lighter blue is the hydrological events like flood and so on. And then you have the climatological events like extreme temperatures. And if you look at even Kerala, if you think about it, we never used to have the severe storms that we get much more frequently now. We had severe flooding a couple of years back. So that is a consequence of what we are facing as a whole planet. And specifically, I'm going to talk to you about Hurricane Sandy, because this was a storm that impacted the New Jersey area when I lived there. And, and I'll talk about how I got into doing some of the work here. So here, what you're seeing is a satellite image of Hurricane Sandy as it was forming over the Atlantic Ocean. And this happened in October of 2012. And soon after the storm, National Science Foundation is our federal agency here in the United States. And they have a program that they support called Geotechnical Engineering for Extreme Reconnaissance. So that is what this GEER stands for, GEER. And so when you have any kind of natural disasters, they tend to provide funding for a team of people to go and collect perishable data. So this is data that would disappear with time, right? So time is of the essence. And this was a team that we had that was deployed for this. And I was the one for New Jersey along with Michael Burlingame. I had lots of my colleagues join me from the Northeast, and then Professor Hashash joined us from University of Illinois, Urbana-Champaign. And so this work is funded by the National Science Foundation, but all of us volunteered our time for this. So what I'm going to talk about is, the geomorphology of New Jersey coast, the wave climatology, where lots of the damage happened was along the barrier islands. So if you look at this map here, you can see that these barrier islands are like these thin strips of land just off the mainland. But there's lots of construction on that. There's lots of homes, actually very expensive homes that are built on that. So when we did an assessment, we looked at coastal bridges, and then we looked at coastal communities, and we documented some of the damage. And I will talk about some of the damage that we saw. So this is giving you an idea of how the storm came about. So you can see it formed in the Caribbean Ocean, and that is typical of Atlantic storms. So this, when we call it hurricane, in India, you tend to call it cyclone, right? So you can see it intensifying and then actually decreasing in intensity as it came on, and it made landfall in New Jersey, just actually south of where I live. But the most of the damage was not near the eye of the storm, but in the surrounding areas, because the wind band for the storm was huge, and you can see that from the satellite image that you saw earlier. So if you look at the coastal hydrodynamics, it varies along New Jersey's coastline. There are 3 wave zones that you see. So this is the southern end of the state, then this is the mid portion, and then the northern end. And here you also have these little inlets that go in. And in fact, some of our team was concentrated in New York, both New York City as well as the surrounding communities. So the coast is divided into 3 zones of different wave climatology. So you see different levels of damage as a result of the storm surge. So Ocean County, which is in the middle here, received a greater portion of the waves which arrived directly onshore from east and southeast. And it corresponded with actually damage patterns that you see in the report. And then you also had huge amounts of water flowing into Staten Island, which is around here. And then you also look at the barrier islands here. They're composed of very loose sediment, which is held in place by gravity and vegetation. And these tend to naturally maintain themselves, but we saw a lot of erosion damage. So you can again take a look at how the waves, so this is normal wave action that you see. And then when you had the storm actually coincided with high tide. So you had a huge surge, a huge storm surge, which caused a lot of erosion along the coastline. And as a result, collapse of some of these sand dunes along the barrier islands. And that is where we saw a lot of damage. So you can see what the tidal surges here are. I hear a bit of noise in the background.
Ma'am, someone has switched on their mic by mistake.
Okay.
We'll be asking them to switch it off.
Okay, thank you.
Ma'am, please continue. Sorry for the disturbance.
So you can see what the tidal surges are here. In this map here, you can see, and like I was saying earlier, that you can see when the predicted high tide was and when the maximum observed tidal surge was. So the storm surge actually coincided with high tide, and that's what you saw, very high levels of water that impacted these zones. And then you have these narrow inlets where the storm surged inwards as well. And you can see later when I show you some of the images. So these were some of the coastal bridges that we visited. They were a mix of drawbridges as well as other bridges, and I'll talk about some of them that we visited. And the reason that we visited the bridges are because bridges are the lifeline structures. They connect communities, and if the bridges are destroyed, that means you can't provide emergency assistance. And so these tend to be critical structures that we have to be careful about. So I will start with Chesapeake River Drawbridge. This is on Route 35, and I know this doesn't mean much. It connects 2 communities called Sayreville and Old Bridge. And it was one of 8 bridges that we visited. The recorded storm damage, this was collected by New Jersey Department of Transportation. It included erosion adjacent to the southeast abutment wing wall here, but the foundation was not undermined. So you can see that, you see this damage, but it was not completely undermined. So it didn't require this serious repairs, right? The barrier gate arm also had some damage from the wind, and it underwent a $25 million restoration project, and it was completed, I believe, in fall 2013, and it included repairing the bridge decks, the side walls, the railings, and the median. So this was the second bridge that we visited. It's a railroad drawbridge, and it crosses the Manasquan River. And it connects the communities of Manasquan and Brielle to Point Pleasant Bridge. And this bridge, as you can see here, is at a very relatively low elevation. with its stringers actually 3 to 4 feet above the water. So our team only assessed the north abutment and found that there was no structural damage. However, based on the surrounding piers, it was suspected there was moderate flood damage in other areas. But we couldn't visit the whole bridge as such because we were not given access at that time. This is another bridge that we visited. This is, again, it was a drawbridge, Route 35. And the drawbridge is elevated and the abutments are back away from the water edge. But what you can see is the damage in the electrical submarine cable room. So, the drawbridge function is impacted because of this flooding in the submarine cable room. We also visited the Mathis and Tunney bridges. So these are located in a township called Toms River, and it spans Barnegat Bay to Seaside Heights. Mathis Bridge is actually a girder bridge with a drawbridge at midspan to allow for ship traffic. And it was closed during a visit due to electrical damage to the drawbridge. And it was also missing a bearing from one of the stringers. The Tunney Bridge, you can see there was erosion. So you see the erosion along both sides, the east and west abutments. So it caused undermining of the roadway and the guardrail. So this is another view of the same bridge, and you can see some more of the damage, and you can see where the sand just got swept up onto the roadway from the surrounding areas. The Mantoloking Bridge was the one that was severely damaged. So we could not visit it because it was not safe for us to visit it. So these pictures actually came from the county itself. The substructure for this bridge, the Mantoloking Bridge, is actually each foundation is 5 concrete-filled pipe piles. The superstructure was a reinforced concrete slab, and the 2 steel sheet pile coffer dams support the bastille piers. And the breach here, you see, it opened up between Barnegat Bay and Atlantic Ocean. And you can see the extreme flooding, erosion, large floating debris, caused the loss of the T-wall as well as destruction seen in this bottom right figure. So this was a bridge that had to be completely rebuilt. And this is actually the rebuilding. So what they did is they drove sheet piles along the breach section. They're hoping that this holds out the water for future storms. They also put in lots of riprap and so on to prevent some of the erosion from happening in the future. This was another bridge that we visited. It's a steel precast concrete bridge on concrete abutments. Some portions are supported by timber pile bends. This suffered significant damage on both east and west abutments, but it still did not undermine the whole foundation. So it did have some damage, the erosion damage that you see. But all it required was some reconstruction of the walkway, some repair of the abutments, but no major structural damage. We also visited lots of coastal communities. In fact, I visited some of these after the team had left also. And so I started with Atlantic City, which was very close to where I lived. So I went down there first. So Atlantic City, we have a boardwalk along the beach. And you can see this was already damaged even before the storm. But what the storm had done was taken some of these sections out. So the high water mark here was about 2 meters, above sea level. The bulkheads run along the section of the shore. So that's what you see here. And it had been breached in 3 locations. And the bulkheads that are used here are wooden bulkheads with tie rods that are attached to deadman anchors. And the pilings for the bulkheads are at 5 feet intervals. And the breaches resulted from damage to the facing and the piles, which had been washed away. So as a result of the storm surge and the water washing in through the breaches, the tie man and the tie rods and the dead man were exposed, and they were severely corroded. So you can see some of the severe corrosion that was, that happened here, and you can see what it has done. It has undermined this whole area. So it caused some of the sinkholes to form and caused, in fact, some natural demolition here. So the ocean took away some of these portions here. Brigantine was actually the community in which the eye of the storm hit, but the damage here was minimal. There was lots of erosion, but not more than that. There was flooding of first floor of many houses. But other than that, it was just minor erosion. You can see that here. And the beach access, in fact, it had settled some, and that's why they have the yellow tape. It had settled about 6 inches, so about, I would say, quite a bit. And I'm having a tough time translating it into centimeters, but so you can do the translation, conversion later and see what that would translate to. One of the other things that we see here is a lot of waste that was generated. So you had a lot of waste from the homes being dumped because things had been flooded and damaged. And and I'll show you the quantities. So you can see here, so when we talk about bulk waste, these are like trees and branches and so on. You also had construction waste that was being generated. So you can see the percent increase from the previous year to that year. So this is what happens during a typical year. This is as a result of the storm the increase in the amount of waste that was generated. So this means it goes into the landfill. So you're looking at a lot more landfill capacity. So Munaki is an area that is actually interior, so not even along the shore, but it is along a river. And what had happened is because of the storm surge from the ocean, the water in the river had backed up. And that caused flooding in the communities around the rivers as well. So you had earthen berms that were breached in 5 locations. In fact, a whole community here had to be evacuated because of these breaches. And then the other thing that happened was the pipeline. So we had natural gas pipelines along these berms, and the buoyant forces from the water caused these pipelines to float up and rupture. So the repair that was done was to place these concrete pads to weigh them down so that in future these buoyant forces wouldn't be able to raise them and cause that rupture. So you can see now, this is 2 areas that we visited after some time, because these were areas we couldn't even access for a long time because there were natural gas pipeline leaks and fires in this area. So we could only go here after a month after the storm. And if you look, so this is in the midsection of New Jersey. It's the area called Seaside, Long Beach Island. It's in Ocean County. So you can see that this is an aerial view of the area, and you can see all the damage, especially close to the shoreline. And then as you went away from the shoreline towards the Bay Area, you didn't see as much damage. So sand was displaced, blocks from the ocean, and it was mostly on the ocean side. The vegetated beaches actually suffered little damage on the bay side, that is on the opposite side. And soil erosion coupled with the storm forces actually pushed over traffic signals, utility poles, and you can see big sinkholes develop as a result of some of the erosion. In Long Beach Island, what you see here is soil was washed out from under the sheet piles, and this compromised the stability of these earth walls. And so So these were the kind of damage that you would observe in these communities. And these are some of the residential homes that you see in this area. In fact, I'm standing here, and this house that you see here was actually on these piles. So it had been sheared off the piles, and it was 2 floors, and 1 floor had been completely washed away, and the owner didn't even know where that home had ended up. While this adjacent property, it withstood the storm and there was absolutely no damage. So you can see that it varied, depending on how things were constructed. So homes that were constructed on shallow foundations, they were shifted or even displaced for a feet off the foundation. And the dynamic water forces destroyed the first floor in many homes and left upper stories intact. In Long Beach Island, in fact, half the homes had flooding and few had very significant structural damage. So you can see that, when you build in these areas, you have to put them on piles, but these piles also have to be designed for sufficient, lateral forces such that it will withstand some of these storm forces. So these are some aerial views of storm damage. This is actually from Staten Island in New York. So you can see before and after images of that, and you can see the number of homes and number of buildings that were destroyed. The other damage that we saw a lot of is boat impacts. So, lots of people have these boats that are moored along the shore, and these had come untethered. So they were just floating around and impacted homes. Some even got wedged between homes, and it caused a lot of damage to the area. This was another one. This is actually an area called Seaside Heights, and this is a very famous pier in Seaside Heights. It's an amusement park. Part of the pier deck was detached, and it was completely destroyed and claimed by the ocean. So some significant damage there. So just in summary, some of the damages that we observed were, in drawbridges, electrical systems were damaged. There were erosion of bridge abutments. We saw some breaches, pipeline damage, the waste generation. I talked about that, a huge volume of waste generated. Boat impacts was another thing that we saw a lot of. Displacement of structures on shallow foundations, and then for some structures, even shearing off pile foundations. So what are some immediate solutions, especially for a warming planet, as we built along communities? So if you ask me, should we have built on the barrier islands in New Jersey? I would say it's not a very good idea, because the barrier islands are almost like shifting dunes. So they tend to move as storms come in, and they have a tendency to move towards the mainland. So these are like shifting sand dunes. So constructing on that is not a great idea. But if you were to do that, what are some of our solutions? I mean, for New York City, we are thinking of putting flood barriers. We're thinking of putting surge-resistant foundations. So we talked about that. These are pile foundations, right? Hardening infrastructure. When we talk about hardening infrastructure, we're talking about how quickly can we bounce back after a storm? How can we minimize some of the damage? Should we discourage development in flood zones? I think we should. And in fact, both New Jersey and New York did that. They actually bought back some of those homes that are in flood zones, and they paid them the market price. So they encourage people to sell. Lifting houses above the floodplain, that is critical. Removable flood wall systems, you see that being done in London, in Venice, lots of areas of the world. In Netherlands, they've had it for a long time. But then are we moving the problem somewhere else, right? So the other thought is to have living shorelines and reefs. So using natural defenses, are those the better things to do? So this is, after image. So these are some homes that were rebuilt after the storm. So you can see now these homes had to be raised by about 5 meters above ground level. So they had to be raised, they had to be on piles. And if you look at this first floor here, these are porous walls. So we call them breakaway walls. So what this allows for is if when a storm comes, the water can flow through. And so it doesn't provide that, so it's not creating these huge lateral forces that would displace the home off its foundation. And that is the reason for this porous first floor construction here. Heating and air conditioning units had to be raised. If not, the flood insurance became very expensive. And lots of homes, like I mentioned earlier, were bought out by the government, by the state governments. In New Jersey, it was something called the Blue Acres program. So these are some strategies that they're thinking of. So this was one of the winning ideas for New York City, and it was developed by Scape Landscape Architecture. And what it is they call it living breakwaters. It is placing these barriers about 1 kilometer. So it's 1 kilometer long of breakwaters, 200 to 370 meters away from the coastline, and 0.6 to 3 meters below mean low water level. And what it does is it attenuates the waves and reduces the erosion. And what it hopes to do is also create habitats for fish to dwell in. So it's called a natural shoreline protection. So they're trying to rebuild fish habitats and oyster populations in this area. And sediments are added to the shoreline to protect these vulnerable breaches. While the breakwaters, it works to accrete the beach elsewhere. So that's the whole point of this. So some of the questions that are raised here, as I present is, do we want resiliency or do we want sustainability? Can we have both at the same time? That is, can we build resilient infrastructure that is sustainable? So if you look at the previous design that was suggested by Seascape, it is possible, but it does require us thinking outside the box and thinking beyond what we have typically done in the past. And then are large-scale barriers a solution? I'm not sure if that's the solution because you're just shifting the problem somewhere else. Should we allow for coastal areas to flood and enhance infrastructure resiliency? Or should we retreat from these vulnerable areas through managed buyouts? And I know that in lots of areas, it's not possible to do that, right? So these are questions that we need to tackle. So with that being said, when we think about educating the next generation of engineers, I would say ethics is a huge component that we should place a huge emphasis on. And the reason is that we want our graduates to speak up and to talk about the impact of climate change and to challenge it. Sometimes you have to challenge political forces and so on to say maybe these are not the best areas to build in. And maybe we need to sacrifice some of that economic development so that we live more sustainably. The other thing that I think engineers should have are good communication skills. I think those are critical because we need to formulate policy, right? And then, you never stop learning, so you have to be lifelong learners. And as you can see now, because of the pandemic, all of us have become very good at asynchronous learning. So you're learning things online, you're learning things asynchronously from your faculty members as well as from others. And then I think it's good for you to put things in practice while you're still in school through service learning by helping communities in need and so on. So those are your hands-on and project-based learning. And I'm a big advocate of that. And with that, I'd like to stop. And I know I have to acknowledge lots of people who helped me in the work that we did in New Jersey when we had to collect the data. And I hope I've kept to my time. And I will stop presenting and answer any questions you might have.
Thank you, ma'am. The session is open for discussion.
Ma'am, do you have any regulation act regarding the construction, Coastal Regulation Act?
Yes, we do, Professor Sajid Kumara. In fact, the flood, it's called FEMA here. They have different zones along the coastline. So V zone is considered the most critical flood zone. So if you are going to build it, you're not allowed to build in certain of those zones. And if you were to build, your flood insurance would be extremely high. So they're trying to discourage building in these areas. So there are lots of regulations. The problem that we're seeing is some of these flood zones that are drawn by this federal agency, FEMA, we are having to revise that almost on an annual basis because of climate change. We are seeing that these areas are changing very rapidly. So that is a challenge that we're facing. And I'm sure that's the challenge you're facing in Kerala as well.
Our Professor Reba is here. She is also from Water Resources Engineering. Reba.
Okay.
Reba. Maybe she left. She's there. I don't know.
Yes, I'm here.
Reba, you can talk to her.
It seems there is some connection problem.
Connection problem.
Okay.
Tajuddin sir.
I have no questions. Actually, the topic, the talk can be used for both the courses which is offered by Kerala Technological University. One is Sustainable Engineering, and other one is Ethics. Anyway, thank you, Dr. Beena Sukumaran, for being with us.
Oh, thank you, Professor Tajuddin. Yeah.
Questions from the student side? MTech Water Resources students?
I'd love to hear from the students.
Yeah. MTech Water Resources students? You can ask questions. All are shy, I think so. Then what about the environmental engineering students? You can ask questions. Come forward.
Morning, ma'am. My
Yes.
question is not regarding the technical aspects of the topic. You were telling about the various skills that have to be developed and specifying on communication skills. So what kind of communication skill training or methodology is being followed in universities there for developing the communication skills for the engineering students?
Yeah, right, Shruti. Yeah, so for our engineering students, in fact, we require them to take writing intensive courses. So we, in fact, they are probably 2 of them. And then the public speaking is also a critical skill that we emphasize. So those are, in some cases, it is inbuilt into what we call a senior capstone. So this is the project course that you do in your final semester. But for us, we do a whole year of a capstone project. So in those, they have to present their work and also write about their work. So we do emphasize both communication skills. And we think that is critical for all engineers and computer scientists. And Shruti, my daughter's name is also Shruti. So,
Nice.
One more participant is there. Her name is also Shruti. From the
Okay.
participant side, ask questions to ma'am. Nobody is asking. Irsha Sheikh. He is a pass. Isha. They are all listened only.
That's okay.
They are not
That's good.
interacting. They are not
Yeah.
interacting.
Yeah.
Maybe because of some shyness.
Thank you, ma'am. Now I call upon Dr. Seena, ma'am, for thanking Dr. Beena.
Oh, thank you.
Good morning, everyone. On behalf of the Seaside 2020 coordinates, I would like to extend my sincere thanks to Dr. Beena Sugumaran, Dean, Miami University, College of Engineering and Computing, Oxford, USA, who accepted our invitation and gave her wholehearted support to the event. She also readily responded to all my correspondence in spite of her busy schedule. Madam delivered an excellent talk on geotechnical challenges posed by climate change and enlightened us. I am absolutely positive this detailed lecture is going to be of great knowledge to our students. Thank you, ma'am.
Thank you, Madam Sina.
Thank you,
It
ma'am.
is, and I hope to meet you in person next time I come.
Okay, ma'am.
Yes, thank you.
Ma'am, are you joining for the next session?
I have to go. Yes,
you have to go now. You
yes. Thank you very much.
Okay,
Yeah.
thank you. Ma'am. Okay.
Thank you. Bye-bye.
It's vacation, no? The Christmas vacation
Yes.
is there. Yeah.
It hasn't. Yes. Thank you. Bye-bye.
Convey our regards to your children also. Sir and Shibu sir. Shibu sir.
Thank you, Seena ma'am, for the vote of thanks. Our next event is the presentation for session 1, Computational Hydraulics. I would like to invite the distinguished chairs for the session, Dr. Shibu A and Dr. N. Sajikumar. A brief intro about Dr. Shibu. He is the Associate Professor of Civil Engineering, College of Engineering, Trivandrum. He completed his BTech in Civil Engineering from TKM College of Engineering, Kollam, and MTech in Hydraulics and Water Resource Engineering from College of Engineering, Trivandrum, and PhD in Water Resources Engineering from IIT Bombay on the topic Performance-Based Design of Water Distribution Networks, considering demand uncertainty by fuzzy probabilistic approach and cross-entropy optimization. He has been awarded the George Woman Memorial Award and Medal by University of Kerala. His areas of interest are hydrology and water resource engineering, application of soft computing techniques in hydrology and water resources, uncertainty modeling of water distribution system, and climate change studies. He has various publications in international journals and conferences. He also has membership in professional bodies like Indian Society for Technical Education and Indian Society for Hydraulics. He has also worked as the technical consultant to Dam Rehabilitation and Improvement Project DRIP and the Air Force. Our next session chair, Dr. N. Sajikumar, is the professor in Civil Engineering Department, Government Engineering College, Thrissur. He graduated from CET, Trivandrum, and completed his postgraduate and doctoral degrees from IIT Madras. His doctoral research was on rainfall runoff modeling in data scarce situation using artificial neural network. He has research experience in various fields of hydraulics, water resource engineering, and environmental hydraulics. He has a total of 75 publications in national and international journals and conferences, and a total citation of 640. He has over 30 years of teaching experience. He also has a vast experience in reviewing projects and many papers in international journals by ASCE, Elsevier, Wiley and Sons, Springer, etc. He was awarded an outstanding reviewer status by the Journal of Environmental Management Elsevier for the year 2016. He's also taken up consultancy and sponsored projects in the field of hydraulics and water resource engineering from national and state level organizations like DMRC for Kochi Metro, AICTE, KSCSTE, local self governments, KWA, KSEB, and various private organizations. He was also the visiting faculty in Asian Institute of Technology, Bangkok, Thailand, under faculty secondment scheme of Government of India from February to May 2012 under deputation. Welcome Dr. Saji sir and Dr. Shibu sir for session.
Thank you.
Thank you, Shruti, for.
Thank you.
Thank you.
Thank you, sir.
Now we'll be starting off with the presentations for the first session. Our first presenting author is Mrs. Shruti Surendran, paper ID 203. Good morning to one and all present here. The project that I'm going to present today is the comparison of hydrodynamic and sediment transport model for dam break analysis over mobile bed. My name is Shruti Surendran and I'm PG Scholar of Water Resources and Hydroinformatics Department, GC Thrissur. Now, dam break analysis is a topic of great importance to many hydraulic researchers, engineers, and modelers because of its massive destructive consequences. Earlier simulations used to be done assuming that the bed was fixed, but due to the significant sediment transport that occurs during a dam break flood and the subsequent morphological changes, morphodynamic analysis is also considered along with hydrodynamic analysis of the when a dam break flood is considered. Now, for any numerical model, it is necessary that we calibrate and validate it. But in the case of dam break study, it is one such domain where there is very little observed data for verifying it against the actual event that has happened. So in such cases, we make use of experimental setups to reproduce a scaled version of the dam break incident and then validate the numerical model so that it can be used to forecast the actual event. Now, my study is also a study that makes use of an experimental setup that has been provided by Frazao et al. And Wu et al. And Frazao and team has provided a benchmark test case for the validation of numerical models that is doing dam break analysis over mobile beds. And my study is an attempt to compare the performance of a hydrodynamic dam break model and an integrated model using this experimental data. And after an extensive literature review, the specific objectives formulated was to formulate an integrated model using the two modules of a software named Telmac Massacre software, Telmac 2D and SISPI. And Telmac 2D deals with hydrodynamic analysis and SISPI with sediment transport. To formulate a hydrodynamic model using only Telmac 2D, run both the models for the experimental data provided by Frazao and team and compare the results. I'm giving a brief idea about the numerical model and theoretical background behind it. This Open Telmac Massacre software might be a new name to many. It is a modeling tool for the use in the field of resurfaced flows written in Fortran and certain scripts in Python language as well. There are various modules to it, and I have used the Telmac 2D that is doing the hydrodynamic analysis of resurface and SISPI that does the sediment transport analysis and coupled it with the inbuilt coupling mechanism in the software for my study. Now, the entire numerical simulation can be phased into three stages. First is the pre-processing phase, where making use of ArcGIS, BlueCanyon, and Google Earth to create the geometry, create the bathymetry file, and the necessary input parameter files so that it is ready for the processing phase. And the processing phase, this model is run using Telmac 2D and SISPI. And after that, in the post-processing phase, we're making use of softwares like BlueCanyon, ArcGIS, and Excel to do the result analysis as per our requirement. Now, in the software, what happens is first we're initializing these computations with certain initial conditions, and this in the Telmac 2D will compute the hydrodynamic parameters and export it to SISPI. SISPI is going to compute the bed load and bed elevation changes and modify the bottom geometry, and this modified geometry is then passed on to the next time step for the subsequent numerical computations, and this keeps continued until the end of the simulation period. The hydrodynamic equations used in this is the non-conservative form of the shallow water equations, and the sediment transport equation is the Mayer-Peter-Muller's equation for bed load transport, and bed evolution is done using the Exner's equation. Now, the methodology adopted here is first studying the geometry from the paper, and all the data is available for numerical modeling is available in the paper with the plume geometry, the plan, cross section elevations, the sediment properties. The Manning's coefficients adopted, the thickness of the sediment bed, the area where the sediment is located. The dam is represented by a gate that is 1 meter long in between two impervious blocks, and the upstream of the reservoir is considered as the upstream of the gate is considered as the reservoir portion, and downstream the downstream area. And all this is modeled in our software as well. After that, there are 8 gauge points located at downstream of the dam, which is taking the measurements of water levels at the end of the experiment. And this water levels is used for the comparison of two models. The dam break wave is triggered by rapidly pulling up the gate, and for a period of 20 seconds, after which the gate is lowered, and it is done for an initial condition of 0.47 meters at the upstream of the dam and 0 meter, that is dry bed condition, at the downstream of the dam. While numerically modeling, we pre-processing by creating the geometry and bottom bathymetry file in ArcGIS, importing it to BlueCanU, and interpolating the bottom geometry with the actual bottom elevation with the flume geometry, and meshing the domain. After that, we are providing the initial conditions of 0.47 meter in upstream and 0 meter downstream. The Manning's coefficient at the sand bed equal to 0.0165, and in the fixed bed 0.01, and the boundary conditions, which is a solid boundary conditions at the upstream and free outflow boundary at the downstream. So all of these data is compiled into a text file with an extension .cas, and it is run in the Telemac software, which has the MS-DOS command prompt window along with the command telemac2d.py and the name of the steering file or the input file. After processing, the binary format is available, which can be post-processed according to our requirement. And for our study, it was required that we compare the hydrodynamic and integrated models by comparing the water levels of both the models with that of the experimental setup at 8 gauge points, as well as the bed levels of the integrated model with the experimental data at 3 longitudinal axes to see if the model is able to depict the morphological changes properly. And first, we have the bed level comparison between the experimental and the numerical model, and it is done at these 3 longitudinal axes. And it is seen graphically as well as statistically that at all 3 longitudinal axes, the models are giving a result which gives a fair agreement with the experimental results, and in the statistical data is also giving us the same information. Moving on to the water level comparison, which is the comparative factor for the hydrodynamic and integrated model with the experimental data. It is first done at the immediate downstream gauge points at the immediate downstream, which consists of 4 in number, and further downstream 4 gauges, which is further downwards. And first, if we check out the comparison at US1 to US4, we see a clear overestimation of water levels by both the models. But in this case, while in US2 and US3, we see that the integrated model is giving a good agreement of result with the experimental setup, whereas hydrodynamic model in all 4 cases are predicting higher water levels. So the reduced water level by the integrated model is indicating the water level reduction due to the presence of sediments. And this US1 and US4, the result exception might be probably the inability of the model to reproduce water reflection from the side walls. Now, moving on to the further downstream from US5 to US8, we see that at US5 there is an ambiguous trend in the water levels measured in the experimental setup itself. So this might be probably due to a likelihood of error in the during the measurement. So that was not considered for the comparison. In US6, 7, and 8, it is seen graphically interpreting. We see that both the models are giving fair agreement of results with the experimental setup. But when we check the statistical comparison, we find that the integrated model is giving us a better result prediction than the hydrodynamic model. So, though the integrated model seem to be at a higher end, we see that there are several limitations that have to be addressed in the model so that a better performing model can be developed. Thus, concluding the study is an attempt to prepare a 2-dimensional dam break model using Telemac Massacre software. A hydrodynamic model was formulated using Telemac 2D, and an integrated model was formulated coupling Telemac 2D and FISP. integrated model was run using the bed load transport equation with no non-cohesive property of the sediments. And both of the models are able to simulate unsteady flow, but the comparison yielded the result that the integrated model is better performing. Integrated model is also able to predict morphological changes depicting scoring and transport deposition. Integrated model results are showing fair agreement with the experimental results, but whatever discrepancies can be attributed to the rough calibration of the friction coefficient, Manning's coefficient, which is an indicative value as mentioned in the paper, as well as the bed material sizes also they say is an indicative value. Both they have mentioned in the paper itself. This work was used as a preliminary step for the validation study of a two-dimensional dam break analysis using an integrated model. These are the references. Thank you. The session is open for questions.
Thank you. Thank you, Shruti and Dr. Shibu.
Hello.
Hello.
Hello. Hello,
Yes,
sir.
sir.
Shruti, you have done a 2D analysis. Why you have done a 2D analysis?
Sir,
Hello?
I had conducted a literature review and yes, sir. Actually, this is a part of a study that I had done for my MTech thesis project, and in that there was enough and more literatures that suggested that one-dimensional results are at the lower end when compared to the two-dimensional modeling. So that was also one of my research gaps in the study. So that was the reason why I did the 2D analysis.
Okay. Yeah, that the numerical models you have used as finite element model or finite difference?
Finite element model.
Finite
It is
element
a
model.
finite element model. Yes, sir.
So, yeah. Okay. So you have considered the mobile bed conditions. What is the result change when it is compared with the static bed conditions in analysis and results? Have you checked anything differences?
Yes, sir. The water level comparison was for that purpose because in hydrodynamic model we are considering the bed is fixed, whereas in the sediment transport model we are applying this bed load transport equation alone for the modeling, and in that we were seeing a clear difference in the water level predictions, where the hydrodynamic model was giving overestimated results at the immediate downstream. Further downstream, the results were not very high, but then again statistically when compared the integrated model results were only giving us results in good agreement with that of the experimental results.
So you have considered only bed load in your study. Why any practical difficulty in doing with the suspended load also?
Sir, actually, this was
Why
a
any
new,
specific reason?
not a specific. This was a new software that I was using. So my first step into the study was to start the modeling with bed load transport and non-cohesive bed properties, as well as for a dry bed condition. And if time had permitted, then I would have extended my studies to a total load as well as wet bed conditions. But again, due to time restrictions. And I've mentioned it as a limitation in the study that only the bed load transport has been considered.
Okay. So you have compared two models and you have specified that this is the most effective. When you compare two models, you cannot say that it is most effective.
No, sir, I
So
will.
it is better than the other.
Yes, sir. Yes, sir. No,
Like that only I have seen
okay.
your conclusion. I have seen.
Okay,
So
sir.
it is most effective means you have considered only two models, and how can you say this most
Okay.
effective?
Yes, sir. Yes, sir.
Okay. Here, so how the performance you have checked by using the NSE, etc. In
Yeah.
which what is observed the NSE values and all the performance measures you have checked.
R square value and NSE value.
Okay. For what purpose NSE value you have checked?
It was just to give
What?
one more statistical comparative parameter for giving us a more concrete result.
No, I didn't get. So what value you have got for NSC for these both the models?
I've got
So
it
how the
between 0 and 1 value. Though the values are less, it is not going to
Okay.
the negative range. Whereas in hydrodynamic model, the ranges are going to a negative level. So that was one of the reasons why the hydrodynamic model was inferred as a
So what
less
about
performing model.
okay? What about integrated model? How the values?
Yeah, except for the immediate downstream for 2 points closer to the wall, all the other points were giving us positive values. The negative values in the first case that I mentioned might be probably because the model is not able to replicate the reflection of water. Whenever there's a water gush from a constriction, the reflection of water that is being reflected from the side walls might not be properly replicated in our model. I have inferred the probability of that negative range may be owing to it, and they have mentioned that also in the journal, saying that they have also seen cases where the replication is not correctly shown in the results.
Okay, can you use these models for the prediction purposes? Prediction of this water levels
Yes,
or okay?
yes, I
How?
have done the study for done the dam break analysis for a masonry dam, Malambura Dam, using this model. Again, with all, it comes with all its limitations, but I've conducted a study and did a comparative study there also.
So in what are the inputs you have to give? What are the input parameters for that
I've
prediction?
Input parameters are the sediment properties we have provided, as well as the boundary conditions, solid boundary conditions of the upstream. The PMF values at the upstream, and downstream it's a free outflow boundary. We have given the initial conditions for the, if it is for the dam break analysis, we have given initial conditions of water levels, reservoir levels, and downstream a derived condition.
Okay, thank you, sir. Thank you, Shruti.
Thank you, sir.
Sir, Sajikumar. Okay. Sir, Sajikumar, sir.
I think sir has left the meeting.
Okay. Wait
Maybe
for some time.
maybe I'll call him.
Okay. So you have used unsteady flow analysis, Sudhi?
Yes, sir. Yes, sir.
Okay. So what are the governing equations which adopted there?
So for hydrodynamic, it is the shallow water equations, continuity and momentum equations, and for the sediment bed load transport, one Mayer-Peter Muller's equation has been used, and for bed evolution, Exner's equation has been used. Both are empirical.
So this kind of studies in literature, anywhere you have seen the FEM is better than the finite difference, etc. Have you seen anywhere that kind of
Yes,
comments?
sir. There are various combinations of studies that is combining. Even if you see this study, this model is though it is making use of the finite element scheme, there are semi-implicit schemes also being used while dealing with the advection terms and all. So there are studies that is saying that finite element is better, but again the computational time and time is more when certain models are used. So that is why finite difference schemes are being used.
Okay. So sir has joined. So in this numerical model, you have used the experimental data. So
Yes, sir.
how many data you have used? How many data you are having?
Sir,
So
this is
data
one
in
experimental setup where the paper is giving us a benchmark test case. It is published as a test case for the purpose of validation of numerical models for dam break studies, And they have also mentioned a team of 12 modelers who have used this experimental setup to validate their models using different boundary conditions, different schemes. So I just, on that context, I used this paper as a good case for validating my model also.
Okay, validating and calibrating. So
Yes, sir.
once it is calibrated,
Yes, sir.
how it will to predict it for the future? Earlier, I've asked that question, and again I'm asking how. So, what type of data or what are the data you are going to input for predicting this whatever the water level, etc. for the future?
So input parameters, we use it based on the case. Like I have used the masonry dams.
Maybe okay, these parameters itself, but how the data, how will you get? So that input parameters, how will you get? So what are the input parameters? So parameters are same, but the values, how will you input?
Values for my study, I
Data
was
sets.
able to get it from various resources like the CWC and irrigation.
No. Okay, no, I'm asking about when you want to go for prediction, what do you do?
Sir, actually, this is one.
Sir. Okay, sir has joined or not?
Sir is not joined.
Hello.
Can we move on to the next participant, sir?
Okay, sir. Okay, madam. Okay.
Let him join.
Okay, thank you, Shruti. Thank you,
Sir.
Thank you, Shruti.
We will move on to the next participant.
Next presenting author is Miss Anju B, paper ID 244.
Good day to all. My name is Anju. I am MTech graduate of Water Sources and Hydroinformatics of GCSU, and my topic of presentation is one-dimensional hydrodynamic modeling of Pamba River for identifying the flood vulnerability. Moving on to the introduction, a flood is an overflow of water that submerges the land that is usually dry. It results in large losses and damage.
Sanju,
The flood caused due to not only by
Sanju,
water, but also by
Sir, it's a pre-recorded video, sir.
Sanju, audio is not.
A thorough assessment of flood is needed.
Stop here. Sir, it's a recorded video. So Anju is there?
Audio.
Okay, 1 minute, sir. Anju is there? Anju B.
Yes, ma'am.
Audio is not clear.
Can you share it now? Can you?
Okay.
The audio is not visible. You have the PPT, no?
Okay.
You just
Yes,
share
ma'am.
it. Okay. Jasmal, you can stop there. Stop sharing, Jasmal.
Good morning, all. My topic is one-dimensional hydrodynamic modeling of Pamba River for identifying the flood vulnerability. Moving to the introduction, a flood is an overflow of water that submerges the land that is usually dry, and it results in large losses and damages. Its main causes are heavy rainfall and human activities. The extreme shift in land use pattern and rainfall trend, a thorough assessment of flood is necessary. The flood modeling gives the prediction of flood extent, depth, and it gives the assessment to risk to life and property in the floodplain. The objective is to understand the hydrodynamics of Pamba River using one-dimensional hydrodynamic model. Moving to the study area, the Pamba River is the third longest river in Kerala and it originates from Pulachimalai Hills in Western Ghats. Pamba shares the northern boundary with Manimala River Basin and southern boundary with Achankovil River Basin. The river stretch considered for the studies between the CWC gauging stations, that is Malakkara, Tumbamon and Kallupara and Totapalli Spillway. This is the Google Earth view of the study area. In this, we can see the three CWC stations Kallupara, Malakkara, and Tumbamon, and the downstream Thotapalli spillway. The length of Achankovil River considered for the study is about 63 kilometers, and for Manimala it is 15 kilometers, and Pamba 38 kilometers. The data required are time series of daily discharge and water level of different gauging stations, and it is obtained from Central Water Commission. Second is the river cross section, which is extracted from dam, and SRTM dam with 30-meter resolution is downloaded from USGS. Then moving to the methodology. First is the extraction of river cross section from dam, then acquiring the stage discharge data from Central Water Commission, then selection of boundary condition depending upon the availability of the data, then to develop the hydraulic model using Mike Hydro River to get the flood depth, water level and discharge at various locations of the river. Then coming to the Mike Hydro River, it is the one-dimensional unsteady non-uniform flow model and it is developed by Danish Hydraulic Institute. It solves one-dimensional hyperbolic dynamic Sven-Venant equation with an implicit finite difference method. And the Sven-Venant equation representing conservation of mass and momentum are given below. The Mike Hydro River consists of 4 modules: River Network Module, Hydrodynamic Parameter Module, River Cross-Section Module, Boundary Condition Module. The first one is River Network Module. It is a central unit. It has 2 views, that is tabular view and graphical view. The second one is the Hydrodynamic Parameter Module and it offers a possibility of specifying user-defined values for a number of variables used during the hydrodynamic computation. Then third one is the river cross-section module, which is the most important module in the out of the 4 modules, and it has 2 data sets, that is raw data and processed data. The raw data describes the physical shape of the cross-section, and the processed data is calculated from the raw data and contain the corresponding values for water level, cross-sectional area, flow width, and hydraulic radius. The last is the boundary condition module. It requires both time series editor and boundary editor. It also has 2 views, that is tabular view and graphical view. Then coming to the result and discussions. First is the calibration of Mike Hydro River. Initially, the Mannis coefficient value is given as 0.033. Then using this value, model was run. Then the Manning's coefficient is given different for different stretches of rivers, and the value ranges between 0.03 to 0.06. These are the graph obtained after calibration. In this, we can see that at the downstream of the river, the observed and simulated values show close relationship. And the correlation coefficient values obtained are given in the table, and we can see that in the Achankovil River, the value obtained is less compared to the others. Then the one-dimensional flood model obtained from Mike Hydro River. In this, the different colors indicate the different flood depth at different location of the river, and in this, the maximum flood depth is obtained in the range of 9.37 to 10.9 meters, as indicated in the red color. Then this is the water level obtained at the different location of the river, and the maximum water level obtained is in the range of 11.96 to 13.46 meter in brown color. Then this is the discharge obtained, and the maximum discharge is 232 meter cube per second. Then coming to the conclusion, the water level and discharge simulated is satisfactory with the observed values, and the downstream correlation coefficient value obtained is higher compared to the upstream. And the variation in the observed and simulated water levels are due to the different datum used for measurement. A correction was made in the topographic data with the known values to get more accurate result. And the model developed using dumb cross sections can be used for simulation of one-dimensional model when the measured cross sections were unavailable. These are the references. Thank you.
The session is open for questions by the chairs. Saji sir has not been able to join yet. Shibu sir, you can continue. Yeah. Shibu sir, you can continue.
Okay. Thank you. Anju, what do you mean by vulnerability and what is the measure of vulnerability? So, what do you mean by vulnerability and what is the measure of this vulnerability? So, what do you have considered?
Vulnerability means the flood extent, how the flood depth is in different location of the river and how it affect the area. And the measure of flood is in meter.
Measure of that vulnerability, how will you measure that you have your main topic is flood vulnerability and some measure should be there for vulnerability. Then what is that measure you have considered? No, okay. Why you have considered in 1D? Hello?
Hello, sir. I can hear
Hello?
you. Sir, I can hear you.
Okay. Why have you? I can't.
Sir?
Hello?
Sir, can you hear me?
Hello?
Yes.
Okay, okay. I can hear. Tell me. Okay, I'll ask question. Why you have considered one-dimensional model? So, any advantage here? The last presentation she has used a two-dimensional model. So here, why you have used one-dimensional model in my career?
Sir, it is a part of my thesis work. I have done two-dimensional modeling also. Sir.
Then why you have picked one-dimensional model? So, okay, I can hear.
Sir, it is a.
Tell me.
It is a part of my thesis work. I have done two-dimensional modeling also, and one-dimensional modeling is
then
very fast. We can get the result.
No, with respect to the accuracy with which or the parameter we are interested, any change in the parameter we are interested, or that the accuracy with which I am asking. One-dimensional is good or better than two-dimensional? So that is the question. So whether in thesis or question. So I am asking whether this one-dimensional is better than two-dimensional in this kind of studies, flood studies.
If we have more accurate DUM, the resolution of DUM is more accurate, and we can go for two-dimensional modeling. But in the case we have done in 30-meter resolution DUM, so the two-dimensional modeling result are just little more.
Okay. So this the 30-meter resolution that SRTM DUM you have used, whether it is sufficient for this kind of modeling, whether it will give good results when you go for 30-meter resolution DUM if you are using.
Sir, I have corrected the DUM after obtained by using this DUM. Then I have more accurate result after correcting the DUM by obtaining the observed values in the field.
Okay. So in this flood analysis, have you considered the effect of dams? In the Pamba River, I think 3 dams are there. Have you considered the effect of dams there? Dams or reservoirs?
No, sir.
In this flood?
I'm not consider the effect of dam. Yes, ma'am.
Okay. So how this study will help in the you have mentioned that it is will policy makers it will be useful. How it will be useful?
Yes, the flood extend how the flood extend to the river, and we can give the measures to that area specifically. Then, when the cross sections are unavailable, measured cross sections are unavailable, we can extract from the dump and do the model.
So when you yourself mentioned that it can be used for mitigation measures. So what are the mitigation measures you can take once you identify the areas, vulnerable areas? If you identify, so what are the possible measures you can take? Mitigation measures you can adopt. What are the possible general mitigation measures?
General, we can construct. Um,
Okay, thank you. Sajikumar sir joined. Sajikumar sir. Okay, Anj. Okay,
I couldn't hear
Sajikumar sir.
the,
okay, thank you, sir.
hello? Because I couldn't hear your presentation right now. Hello? Now I connected.
Okay, sir.
Anju. So, hello?
Hello, sir. Hello, sir.
No, I couldn't hear her presentation. Anyway.
Sir, can we move to the next presentation? Can we move on to the next presentation?
Yeah.
Okay. Thank you, Anju.
Anju, one more thing in your paper, it is one statement is like that Kerala faced with devaluated flood in 2018, and whether it is correct or not. Devaluated, like that only mentioned. Devaluated flood in 2018, and one state was like that. One page, one paragraph it has written like that. So you check it. Devaluated like that.
Okay, sir. I will check, sir.
Thank you. Okay, thank you. Anj.
Thank you, sir.
Thank you.
Moving on to the next presentation.
I'm sorry for the disturbance because see, there was some power failure and connected issues. I'm sorry. Please continue.
Okay. Thank you, Saji sir. Thank you, Shibu sir. We are moving on to our next presentation. Our next presenter is Miss Anupriya A, paper ID 327.
Now, so her sound is very feeble.
No. Anupriya, presentation also not visible.
Presentation is visible.
Sir, Anupriya, could you please do the live presentation, please?
Can you hear me?
Yes, you're audible now. Yes, you're audible now.
Yes, I can share.
You can share your PPT now.
Okay.
Hello, can I start? Hello,
Yeah, yes, you can start.
good morning all of you. I am Anupriya from Government Engineering College, Thrissur. My topic is flood modeling and breach analysis of Peruvenu River in Kerala state. Coming to the introduction. Before entering into the full topic, we should understand what is hydraulic analysis and hydrological analysis. analysis of flow properties of a river is termed as hydraulic analysis, and that of the watershed characteristics is termed as hydrological analysis. This uh, these properties, flow properties, includes rainfall distribution, runoff in the basin, then flow depth, stage, bed shear stress, velocity, etc. So, continuous variations in these flow properties due to hydrological changes causes morphological changes in the river and river banks. This, therefore, this hydraulic and hydrological analysis is very important or plays a major role in taking measures for the mitigation of river-induced problems like flood. During the catastrophic flood in 2018, Kaduvallur River, which is one of the largest river in the Thrissur district of Kerala, changed its usual course of flow, disrupting the bund road connecting Arathapura and Kaduvallur. The state of river spread to several kilometers, submerging hundreds of houses and acres of land. So, the situation indicates the necessity of conducting hydrological and hydraulic analysis of Tiruvallur River. This figure shows the diverted Kairali River during the flood 2018. And coming to the objectives, mainly three objectives. To conduct a simulation model study of the river using hydraulic and hydrological models, to identify the causes for the river diversion, to propose a river management plan. This figure shows the stream network map of Kairali River Basin. The basin has a drainage area of 1054 square kilometers and a stream length of 48 kilometers. Coming to the methodology. In order to find the causative factors for the river diversion and bund breach, a small stretch is used for the study. That is, a 5.460 kilometer is used for the study. That is the reach in which the bund breach was actually selected. Here, the red point in the enlarged view of the study reach indicates the point of bund breach, and for the modeling, the junction point of Manali and Kurmali River is used as the upstream endpoint. The 2D modeling of the river was done using HECRAS 5.0 software, and the important input data are cross-section data, upstream boundary conditions, downstream boundary conditions, and this cross-section data is derived using HECGORAS, which is an extension of ArcGIS, and the flow hydrograph is used as upstream boundary condition, and normal depth is used as the downstream boundary condition. This flow hydrograph is derived from HECHMS model, which is a rainfall runoff model, and this figure shows the terrain model of the Kaduvallur River Basin. After the results are obtained, both the models are calibrated and validated using the daily discharge data from Irrigation Design and Research Board, Trivandrum. And in the HECRAS model, the calibrated Manning sign value for the river is 0.04 and for the banks is 0.06. And using the modeling results, a proper river management plan could be proposed. And this figure shows the calibration and validation graphs of HECMS and HECRAS models. Coming to the results, this figure shows the flow hydrograph from HECHMS. And from the figure, it is clear by 15th August 2018, the discharge in the river started to increase rapidly, and it reached a maximum value of 699.5 meter cube per second. Then again, it started to decrease. So, and also one more point is this graph shows on the flow hydrograph only due to the rainfall. So the average annual discharge value of the stream is to be added with these values, and it is to be given for the HECRAS model. This figure shows the flood mapping of the river on 15th, 16th, 17th, and 18th August 2018. That is, this figure shows the extent of flood. From this figure, we can see the extent is the extent of flood is maximum in between the 16th August and 17th August 2018, and again by 18th August 2018 it decreased. And also the red arrow in the figure indicates the diversion of river diversion and river diversion. That means when the water with enormous discharge when entered through this highly curved portion, the sidelines of the river gets weakened and the scoring action developed by a tangential force due to the curvilinear flow through this highly curved portion. So, this is one of the main reasons behind the river diversion and bund bridge. That is, when the water with high discharge or velocity uh, entered through this highly curved portion, a tangential force was exerted, and the force with water with high force hit on the bund road, and bund road was collapsed. And in order to find the maximum flow and the shear stress or other properties, a region between the river sections A and B is selected. And here the maximum flow is obtained nearly equal to 750 meter cube per second. And the maximum bed shear stress is in the range 38 to 100 Newton per meter square. The maximum depth of water in the river reached with respect to the channel bottom was 15 meter, obtained as 15 meter. Here, this graph shows the flow hydrograph in the region AB, obtained from Hector's model. And this is the bed shear stress at section A and B. And one more point is, bed shear stress is also an important parameter, because as the bed shear stress increases with increase in velocity, the scoring action also increases. So this leads to the entire bank failure. So this is also main reason for the river diversion and bund bridge. Coming to the river management plan, this figure shows the elevation profile of the section where the diversion occurs. From this figure, it is clear the area beyond the bund road is at a very low level. So the spreading of water is easy in this situation. So the wide spreading of water over the large low-lying areas could be or can be proposed by can be prevented by proposing a proper river management plan, or by constructing a river management work. So here in this study, I have proposed construction of a levee, and as I told, the maximum depth of water or maximum water surface elevation in this river with respect to the channel bottom is 15 meter. So, including providing an extra of 1.5 meter as freeboard, the top of the levee should be at 16.5 meter from the channel bottom. And the total height of the levee, the exact height of the levee cannot be determined, because the information or data about the soil conditions and river bank lengths is not available. So the total height of the levee cannot be determined, as it depends on soil conditions and river bank lengths. Coming to the conclusion, after variations in discharge, bed shear stress, and other flow properties led to the river diversion and bund bridge, and when the water with enormous discharge entered through the highly curved portion of the river, a tangential force was developed, and the sidebanks of the river was weakened, and this caused the overflow of the river towards the right bank and overflow of the river towards the right bank and the bund bridge. And construction of the levee on the right bank is proposed, and top of the levee is at 16.5 meter from the channel bottom, including a freeboard of 1.5 meter. And one of the limitations in the study is data insufficient, because the Mannix and coefficient and cross section is assumed as constant in this study. And also the exact flow hydrograph was not available and in that time. So I used the flow hydrograph derived from rainfall runoff model. So this is one of the limitations in the study. These are the references for the study. Thank you.
The session is open for questions from the chair.
Priya?
Yes, sir.
What is basic difference between hydrology modeling and hydraulic modeling?
Sir,
Because you are trying to compare these two, you know?
yes, sir. Sir, actually, the flow properties are analyzed in hydraulic analysis. Most of the flow properties are like in the river. So, hydraulic analysis.
I am asking with reference to the governing equations.
Governing equations means hydraulic analysis is used then using continuous momentum equations, energy equations, and hydrologic analysis. The equation so, I don't know.
Hello?
Hello? Hello?
Yeah, I am asking about the basic difference in the governing equation with reference to hydrologic modeling and hydraulic modeling.
Hydraulic modeling is
Hydraulic modeling, you said it in the right. What is the basic governing equation in the hydraulic modeling? Hydrologic modeling.
governing equations.
Okay, you said about the see what is the basic scheme that is being used in the HECRAS? Scheme of solution which is being used in the HECRAS?
I didn't get you on the question. I didn't get
Pardon?
scheme means what? Scheme of solution means
Numerical solution. See, basically this is a numerical solution. Am I right?
yes, yes, sir.
So what is the scheme that is being used?
Actually the continuous equation as per the continuous equation or energy equation, the modeling is done using HECRAS.
No, you said that the boundary condition normal depth is being used at the downstream side. Have you taken any precaution in using that boundary condition?
Yes, sir. The water surface elevation and water depth is assumed as.
No. My question. See, basically, this is an unsteady flow. Am I right?
Yes, sir.
This is an unsteady flow. In the unsteady flow, the uniform equation is not strictly valid. So of course, we will use the normal depth downstream. Then, have you taken any precaution in using that boundary condition?
I have assigned frictions law for the for giving normal depth for getting the normal depth. So I didn't get the question, sir.
And see, basically, you said that you have got a level of Levy level of 16.5 meter. Am I right?
Yes.
What is the ground level there?
Sir?
What is the ground level there?
Sir, I just set for 0, and I have calculated it from 0 as.
Now my question is, what is the ground level? Ground level which you proposed, or what is the bed level of the stream which you have assumed? That is a cold line area, isn't it?
Yes.
So when you say a level 16.5, how much is the height? See, I would like to know the height, actual height of the levee.
Actual height of the levee cannot be, sir. Actually, the top of the levee should be is only determined.
No. See, what you are getting is with the reference to the bottom elevation which you have given.
Yes.
Am I right?
Yes, sir. Actual elevation is not. I'm not remembering. Sir. It is taken from as 0. I think that and surface is thickness 0.
I am done, Dr. Shibu. Dr. Shibu.
Thank you, sir.
I am done.
So, okay, thank you. Okay, thank you, sir. Anupriya, why you have selected this as your study region? Any specific reason for selecting this as a study region? This river region.
I put the study region near to the bund, near to the bund, and there is a in order to find the course for the river diversion, that the study reach should be selected near the bund reach. So I selected this reach, and the data also available.
So, okay, what are the river-induced problems? Generally, river-induced problems, and generally river-induced problems. What are the problems?
Flood is one of the induced problems.
Here, in your study, what was the main problem you have identified? And correspondingly, you have provided as in your problem, in your case, your study. So, what was the main problem you have identified from
Actually, Karivannur River, the area near the Karivannur River is at a very low level. So when the water in the river or the discharge in the river increased, in most of the years the residential areas near this river will be flooded. So that can be prevented by proposing a construction river management plan. So this is the main objective of the study.
Okay, this is the only option. The levy construction of a levy is the only option that. What is the problem you have identified? Solution to that.
No, sir. We can propose
What are the alternate?
drawings,
What do you mean?
the drawings or guide banks can be constructed, but hello.
So you have mentioned somewhere tangential force having an effect. So why a tangential force comes into picture?
When the water, there is a highly curved portion in that region or that near to the boundaries. So when the water entered through that highly curved portion, a tangential force developed. That is, water with a high force flowed over the right bank. That's why I called it as a tangential force.
So you have used this HMS and ECRAS. Each one is hydraulic model. Which ECRAS is hydraulic model or hydraulic model?
ECRAS is hydraulic model.
You have used two hydraulic and ECRAS is hydraulic.
Yes, sir. ECRAS is hydraulic model.
So
HMS is hydraulic model.
And what about HMS or hydrologic? Okay.
Hydrologic model. It is done using the rainfall data precipitation.
No, you have not answered clearly. The answer was not clear, I think. So, what is the effect of bed shear on this software? So, you have studied. So, what is the effect of bed shear?
Sir, when the bed shear stress increases, the side banks also gets weakened. So, the entire dam fails and the water will be overtopped towards the dam. Over the.
Okay. Thank you, Priya. Sir, Sajima, sir.
Any more question from the audience? So if it is not there, we will proceed with the next one.
Thank you, Anupriya. Our next presenter is Professor Indulega KP, paper ID 269. Anupriya can stop sharing her screen.
Good morning. The topic of my presentation is simulation of flow pattern around series of drawings with the different orientations in meandering channels. Myself, Indulega KP, and my co-author is Sachin S. We are from College of Engineering, Trivandrum. The mechanism of flow and turbulence around drawings in a meandering channel is a very complex phenomenon. A better understanding of turbulent flow is needed to analyze sediment transport problems in meanders. The mean flow and turbulent distributions around these structures has to be analyzed properly. Groins are normally used to prevent bank erosion and to keep the main channel navigable in natural rivers. The complexity of flow around these series of groins increases with the development of scour in meanders. So the objective of my study is to analyze the flow pattern around series of groins in meanders for erodible bed under different orientation angles and to identify a suitable orientation of groin in meanders. At first, physical experiments were conducted in a meandering flume featuring a meandering portion of a Vamanapuram river in Kerala, and the model was set up at PG Hydraulics Laboratory of College of Engineering, Trivandrum. The curved portion of the river was selected and it was scaled down to a horizontal scale ratio of 1:60 and a vertical scale ratio of 1:20. The flume consists of three consecutive and opposite bends with angles 67 degree, 134 degree, and 67 degree, and it is named as bend 1, 2, and 3. The central angle of 134 degree in bend 2 represents a typical meandering geometry. The physical model has a cross section with a base width of 50 mm and a top width of 130 mm, and the side slope of the model was 39 degree. The figure 1a shows the physical model set up in the laboratory, and the same model flume was created in the ANSYS fluent, and the flume geometry is shown in figure 1b. 6 groins were placed in bend 2 with a spacing by length ratio of 2.5 and at an angle of 45 degree. Figure 1c shows the position of groins and the various sections used for numerical analysis. The groins were numbered from G1 to G6 and sections were numbered as X1 to X5. The velocity was computed from the numerical model is compared with the velocity obtained from the physical model, and the figure 2 shows the comparison of velocity from numerical and experimental model. And the results found that the numerical model shows a good agreement with the experimental results. The various parameters such as pressure, velocity, turbulent kinetic energy, and streamlines were analyzed for different orientation of groins from 15 degree to 150 degree. And figure 3 shows the pressure contour developed for different orientation of angles. The pressure contours were analyzed, and it is found that the maximum pressure was observed in the 150 degree orientation, and major pressure variation was observed around the third and fourth groin. The most pressure variation was observed for 90 degrees center, and the variations were concentrated on second, fifth, and sixth groins. Figure 4 shows the velocity contours for different orientation of groins, and from the contours it is found that the velocity was very low in the groin field for 15 degree and 150 degree alignment, but nearer to the groin tip a dynamic fluctuation in velocity was observed. For 30 degree and 45 degree, the velocity increases as it enters the groin field, and then it decreases after the groin field. But for 90 degree and 120 degree orientation, the velocity increases throughout the field. The groin of 15 degree and 150 degree experience the most number of velocity variation. The velocity decreases as it enters the groin field for 45 degree and 30 degree angle, and the maximum velocity was observed for 90 degree angle. The figure 5 shows the turbulent kinetic energy contours for different orientation angles. And it is found that the maximum turbulent kinetic energy was observed for groin of 90 degree angle. For the groin orientation of 15 degree and 150 degree, the similar patterns were observed. For 45 degree and 90 degree show less variation in turbulent kinetic energy when compared to other angles. And the variations were mostly concentrated around third groin. Figure 6 shows the streamline pattern for different orientation of groins. And it is found that a large number of vertices were developed in the groin field for angles 50, 90 and 120 degree angles when compared to other angles, and the vertices were developed in between first and second drawing for orientation angle of 90 degree and 120 degree. For 15 degree, the flow line submerges into the drawing field region that will causes the erosion of the bank in the drawing field. So 45 degree can be chosen as the best orientation for meanders, and thermal kinetic energy at different sections for 45 degree angle were analyzed, and it is shown in figure 7. It is seen that the thermal kinetic energy was more for section 1 and section 2 in compared to other sections. So as flow approaches the downstream of first and second drawing, the kinetic energy was reduced. The kinetic energy pattern were almost the same, similar for section X3, X4 and X5. Figure 8 shows the variation of velocity at different orientations, different sections for 45 degree angle, and it is found that except for X1, the variation of velocity is similar, and the velocity reduction was more for section X1 when compared to other angles. But for all sections, the velocity was lesser than the approach velocity of 0.41 meter per second. So 45 degree angle is found suitable for velocity reduction in meanders. From the modeling study, it can be summarized that 90 degree orientation has shown the most dynamic variation properties like pressure, turbulent kinetic energy within the growing field. The analysis of spring lines helped to identify the position of vertices and thereby the position of scouring. 15 degree and 90 degree orientation has shown most number of vertices within the growing field, and these vertices are more concentrated after the first growing. For 45 degree angle, the velocity gets reduced by almost 50% at the downstream of first growing. From the analysis, it can be concluded that the numerical modeling is found to be very effective for the analysis of flow pattern around growings. Even though growings aligned at 15 degree and 150 degree with the bank showed these variation in velocity, but it cannot be used as a river protection path as it does not deflect the flow away from the banks. 90 degree orientation is not suitable in meanders as it has shown most dynamic variation in pressure and turbulent kinetic energy within the growing field. The maximum values of pressure, velocity, and turbulent kinetic energy were experienced in the tip of the growing. The ideal angle for controlling velocity was found to be 45 degree as 30 to 50% reduction of velocity was observed when the flow reached downstream. These are the references. Thank you.
Hello, Professor Indileka. Hello.
Hello, sir.
Yeah, I have a few questions regarding the modeling process. How much is the discretization that is being used? What is the, discretization level that is being used? Because discretization has a very high importance with the reference, especially in a numerical model, especially in Fluent. Discretization has a very high importance. So you haven't mentioned anything regarding the discretization part. Hello? Hello?
Hello.
Will you be able to hear me?
Sir, hello?
Yeah, I would like to know the discretization part. Say, how much is the, how many elements and how many, what is the size of the element and so on, minimum size of the element and so on and so forth. Because the discretization in numerical model, especially in Fluent, when you are using, especially in Fluent, the discretization size of the element makes a lot of difference.
Sir, the size of the element used is around 0.5 into 10 raised to minus 2. 0.005 into 10 raised to minus 2. the size of the element was, and the maximum size of the element was 0.5 centimeter. And the number of nodes used was around 37,000.
How much is the aspect ratio used? How much is the aspect ratio used? Have you checked the aspect ratio?
Sir, one of my co-author is also there. I think he can explain more about it. He's done the project. Sachin, the number of elements used was 27,000, around 27,000. And the node used was
I'm
37,000.
asking about the basically about the aspect ratio and the minimum size of the element. Hello.
Hello? Sachin, can you
Yes. Hello.
the size of the element used is around
Hello, can you hear me?
0.005 into 10 raised to minus 2, I think. Sachin, can you answer this question?
Actually, the size of the element was like 0.05 meters.
Okay. 0.0. So how many elements total?
Yeah, it was almost like 27,072 elements, and number of nodes was 37,928. Since the system was very small, very big, we didn't scale it down. We used the actual measurement itself, and we
Have you used the model or have you used the original prototype? Model or
no. Actually, we had the model, and we didn't scale it down. We used the actual measurements itself.
Okay. So how much is the aspect ratio?
Aspect ratio, I don't know, sir.
No, because see, basically when you check the element size and other things, the aspect ratio plays a major role. It has to be less than 10. Not vertical, the lateral dimension and this one. And another thing, I see, you have been talking about the pressure variation. What is its pressure variation within the flow domain? What is its physical importance? So within the say when the groins are provided and this area has a lower pressure and pressure varies in this area like that. What is its physical importance?
So actually, what we did was like we wanted to compare that how the pressure will vary along different sections.
That's all right, but what is its physical importance? Say if it varies, what happens?
Oh, if it gets more that like we can use it for the bank protection, right?
Because of why?
Because as the pressure increases, we can't use it for the bank protection works for the groin.
No, I am asking about the physical effect when the pressure difference occurs. Physical impact of that on how does it act in the actual situation? Now, have you used the same mesh everywhere, or have you used a refined mesh near the groins?
No, same mesh everywhere.
So naturally, there will be a lot of difference in the actual situation. See, basically, when you have a variation very near to the very high variation in a particular region, you need to use a refined mesh in that area. Otherwise, you won't get a correct picture of what exactly happening there.
Okay, sir.
Okay, I'm done. Okay.
Hello, sir. Hello, Indileka. Have you done this for the state reach digital and how it is different in curved portions of the work? So is it for the same orientation, whether it is effective for curved portions also? Hello.
Sir, I didn't get the question. It was not clear.
you have studied straight reach of the channel, this orientation of these groins, etc. You have considered for the case of straight reach of the channel. Is it all? Is it like that or hello?
The groins were placed in the meandering section. Sir, the modeling was done for the curved channel, curved section. For straight section, the alignment will vary. For straight section, the alignment may vary.
The 45-degree inclination is for the curved portion, curved regions. It is effective, as you mentioned, it is effective for curved regions or curved portions of the channel.
Yes,
is it all? No? Okay. Then what?
Yes, it is.
This orientation, by you mean that it is normal to the direction of flow or it is inclination to the bank?
It is inclination to the bank, with the tangent to the bank.
Okay.
Inclination from the tangent to the bank.
Okay. So that is to the direction of flow, opposite to the direction of flow, you are orienting. So that means 10 degree, 25 degree like that. So how the 150 degree way of on base 150 also you have mentioned.
150 degree with the flow direction. 150 degree with the flow direction. And from the channel 30 degree. From the channel bank, it is pointing downstream for 150 degree. The flow will be pointing downstream.
Okay. So that 45 degree we are 45 degree orientation which gives the most effective here. You are saying it for the third portions. And what about if you are supposed to use in the straight portions, what orientation it will give the best orientation you are observing?
I have done the experiment for straight section also in the physical model. In that, it is found that 45 to 75 degree is effective. That was my preliminary work. In that,
and
for straight channels, 45 to 75 degree is suitable. Found suitable.
One more question regarding this. What about the length of the groin effect to this type of velocity, etc.? So whether you are giving the length or the entire width, not the entire width, you are supposed to give half of the width of the river, etc. You have to give like that, or length will be more than half of the width of the river.
So in this experiment,
so you have considered length.
I have conducted the experiment with a length of b/6, where b is the base width.
Okay.
Normally, it is length should be less than b/5 as per IS code. So I have done the experiment for b/6 value. So if length changes, then the flow pattern will also change. The length changes, the flow pattern will also change. That has to be studied.
Okay, so you have done by keeping the length of the groin constant, and for different orientation you have done this study. Okay, so in that case you have got 55 degrees the best option, best orientation. So for curved portion on the river. Okay. That will be different for simple curves and reverse curves. It will be different. Meanders will be like that. Okay. So curves.
It has to be studied in detail for different curvature. It has to be studied for different curvature. That can be as a for future work.
Okay. Thank you, Indulekha. Thank you. Sir, Sajid Master.
Thank you, sir.
Okay.
Yes. Any more questions from the audience? One more small question. See, basically, why did you go for a 2D model?
Sir, in three-dimensional model, it should be a complex phenomena when scouring is considered. So I have chosen 2D model only. It will be more complex.
Basically, this covering, as far as covering is concerned, it becomes a 3D effect, isn't it?
Yes, sir.
Anyway, that's all. I am done. If there is there any question from the audience? If so, we'll stop.
Okay, thank you, sir.
Okay, thank you.
Thank you, Professor Indulekha. Our next presenter and the last presenter for the session is Ms. Jesslyn Jose, paper ID 479.
Respected professors and all others who are present here for assisting my paper presentation. Myself, I am Jesslyn Jose, I'm tech student from Government Engineering College, Thrissur. My co-author is Dr. Sumam KS. She is Associate Professor from GEC Thrissur. And my paper topic is Upstream Flood Hydrograph Prediction of Chalakudi River. Moving to the introduction, we know flood is one of the most frequent disasters in the world. According to World Health Organization, from 1998 to 2017, about 2 billion people are affected by flood. In 2018, there occurred a massive flood in Kerala. It is known as the flood of the century or level 3 calamity. According to the studies of Indian Meteorological Department, there was about 42% more rainfall than any year, and this extreme rainfall created a huge runoff, and this runoff reached the dams. The dams were already almost full due to the monsoon season, and the authorities were in a situation to release this huge quantity of water in a short span of time, creating a massive flow of flood water in the downstream areas. In that flood, we lost about 483 people. And we know in any flood modeling study, the flood hydrograph is a crucial element. The flood routing, it is a process of determination of the downstream hydrograph from an upstream hydrograph. But due to certain reasons like lack of gauging station at the upstream, this flood routing may be there can be some difficulty in proper flood routing. In such situation, we may have to adopt the reverse routing technique. Reverse routing is the determination of upstream hydrograph from the downstream hydrograph. It has various applications or requirements. We can see some of these examples. First of all, disputed river lease cases. When we are considering Tamil Nadu and Kerala, the upstream hydrograph is located in Tamil Nadu and the downstream is located in Kerala. And if there exists any dispute in any of these river casing stations, we may not available this upstream data for a flood modeling study in the downstream. And also, for various flood modeling study, we may require an upstream gauging data. And the gauging station may not be available there. Or due to some human activities like sand mining, it may affect the performance of the gauging station at upstream. In such cases, we may have to get more better results. In such cases, we may have to go for a reverse routing or for verification and recalibration of newly installed instruments or for maintenance work also we may have to adopt this reverse routing technique. And when we look into the literature, there are the reverse routing area. It is a less attended area in the water resource studies. There were some studies more in previous. All these studies were depend on typical traditional reverse routing technique. In 2005, Doki and Bloom conducted some reverse routing studies, and they concluded that the reverse routing process has difficulties of an inverse problem. It is ill-posed, and the computations are always subject to instability. As an Indian paper in 2009, Class A suggested the need for fresh calibration of parameters if we are using the Messinga models for reverse routing. And in the recent, I looked into some recent studies in 2015. Suko et al. Proposed a model for reverse routing using genetic algorithm, which is an artificial intelligence technique. In 2017, as an extension of the study conducted by Suko et al. In 2015, Kaya et al. Conducted a flood modeling study in Turkey by taking the methodology that is suggested in the previous paper. And when we look into all these studies, We can see the studies are limited in the reverse routing area due to the practical difficulties, and we can see the model later studies are adopt either statistical or some artificial intelligence for the easiness. And my aim of doing this work is to check the adaptability of reverse routing process suggested by Sukhu et al. In 2015 and Kai et al. In 2017 in Indian condition by taking example of one of the most flood affected river in Kerala during 2018. That is, my objective is to predict the upstream hydrograph for a riverage using the downstream hydrograph by a reverse routing process. My methodology comes under main three headings. First of all, it is the identification of study area. Next one is the data collection and analysis. And third one is the reverse routing model. The study area selected is Chalakudi River, and the Chalakudi town is located on banks of this river. There was flood in 2018 and 19. It indicates a possibility of flood in future also. The Chalakudi River is a tributary of Periyar River, and it is the fifth largest river in Kerala. It has a drainage area of 1,704 kilometers square in total, of which 1,404 kilometers is located in Kerala. It has a length of about 145.5 kilometers. It has a gauging station at downstream of the town at a place called Aranali. It is a gauging station of Central Water Commission. The Chalapuri town is one of the most flood affected city in Kerala flood of 2018. So I have decided to do the event modeling at this study area. These are the certain pictures of 2018 flood. This is the slum area. Here you can see the NH. The area is fully round. This is the meandering portion of Chalapudi River. Here you can see this is the well-known Adrapalli waterfalls. So here you can see the first floor, even the first floor of the building is going to be drawn soon. This is the study area. This is Chalapuri town. Here you can see the river. This is the Aranali gauging station. This is the downstream gauging station and located downstream of this town. And I have mainly I need discharge data, water level data, velocity data, etc. And I collected this data from Central Water Commission, Bangalore and Coimbatore. And about the reverse flood routing model, I use the reverse flood routing process using the iteration procedure of genetic algorithm. The basic principle of genetic algorithm is the survival of fittest, and the basic continuity equation is used for the iterations. And the mean objective function. My objective function is to minimize the mean absolute error, that is equal to the difference in QD model. That means downstream discharge computed by the model and the downstream discharge observed, and to minimize the error between these two. The parameters and function that result in the best solution is determined and then calculated the upstream hydrograph. This is the reverse flood routing procedure. Here it is the equations. The upstream hydrograph is an unknown graph. So we assume that it have a shape of log Pearson type tree distribution, and the parameters are selected so as to match the requirements of the hydrograph. And the basic routing equation is the upstream hydrograph plus lateral minus downstream is the changing storage. Here the second equation is modified. Downstream is equal to upstream plus lateral minus changing storage. And the fourth equation is the relation between storage and downstream stage. And the fifth equation is the relation between lateral flow and the downstream discharge. First of all, we'll assume the initial values, the unknown values, and then we will compute the upstream hydrograph, and I will compute the storage, then compute the lateral discharge, and we'll compute the downstream hydrograph value. Then the downstream discharge value is equal to upstream discharge value plus lateral discharge minus storage, and I will compute the mean absolute error, which is the objective function. This objective function is satisfied. This optimal values of parameters and coefficient is selected for the computation of upstream hydrograph. Else, this iteration is continued using genetic algorithm procedure, and every time the parameters and coefficient values are updated. And the best one is chosen for the computation of upstream hydrograph. Moving to the result and discussion, reverse flood routing model was created in Excel assigned arbitrary values. Genetic algorithm method was used for the optimization using the software Evolver 8.0. Evolver 8.0 is an extension of MS Excel and it works in the platform of MS Excel. This software uses the recipe solving method and this it was developed by Parisite Corporation Limited. And upstream hydrograph is computed by the appropriate selection of parameters and coefficients obtained by using this model. These are the constant values used in this, that length of lower ridge and width of the lower ridge, and adjustable cells are the unknown values of parameters and coefficient. These are the indications, and this is the minimum and maximum range given. And the system, the software itself works in between this range and selects the best one. These are the values. Here we can see the mean absolute error comes to 84.65 meter cubes per second, and the error is less than 4.6 percentage. This is the model that created in the Evolver for solving this problem. Here we can see the observations in a graph format. This blue color is a downstream discharge computed, and the red color is the downstream discharge observed. Here you can see both of these graphs seems well, that is the error is minimum. Here also we can see the green one is the upstream hydrograph computed, and the red one is the downstream discharge observed. Here we can see the error very short, about 300 meter cube per second. And the major observations are hydrograph shade parameters comes the value between 1 to 1.5 and the volume comes to 1 to 1.1. The storage coefficient comes to a value of 1 to 1.1, and lateral flow constants are very less because we have not considered any lateral flow in the selected. There is no lateral flow in the selected reach, and the mean absolute error is 84.65 meter cube per second, and the error observed is 5%. The variation of discharge comes to about 300 meter cube per second, the time lag of 2 hours. And moving to the conclusion, reverse routing model could predict upstream hydrograph with a mean absolute error of 84.65 meter cube per second, and the error is less than 5%. If there is a data deficiency, we can adopt these types of artificial intelligence technique to get a more reliable results for our studies. And the limitations, there are certain limitations in the study, and they arise from the assumptions that are used in the equation used to develop the reverse routing model. These are my references. Thank you for your attention.
This session is open for questions from the chairs.
Hello, sir.
Hello, Sadi sir and Shibu sir. You can.
Hello. Jesslyn?
Yes, sir.
So, you have mentioned that there is some. Professor Shibu, please.
Okay. Okay. Sir, are you asking questions or whether I should?
No, you proceed. I will ask it later.
Okay. Jesslyn, in this reverse flood routing process, you have used GA. What is the using used?
Sir,
Don't you use the common? So it is violating the governing equations as in the flood routing. Now flood routing, we are using some governing equations, and when you go back to the reverse flood routing process, you are violating some of the governing equations in which how it will match with.
Sir, mainly the aim of my project is to check a better procedure when there is a data deficiency. Here in this case, we doesn't have an upstream hydrograph. So I am checking whether we can use predict the upstream hydrograph using an artificial intelligence technique. So it's the basic only the continuity equations used for this process.
What are the major consideration in the reverse flood routing in your case?
Here I have considered only a limited number of cases. First thing it is the downstream hydrograph, then storage, and there the lateral flow. An option for only these three things are considered. And in my considered reach there is no lateral flow. So the mainly the continuity equation is used here. That means storage, downstream hydrograph, it's a discharge, and water level data.
Okay. What are the objective functions and constraint here? Only one objective function or?
Only one objective function to minimize the error between downstream observed discharge observed by the actual downstream discharge and the discharge predicted by the model.
Okay. And constraints? What are the constraints? Constraints in the algorithm we have used.
Yes. Constraints means I have given the constraint as the range where the parameters and coefficients can go. That I have given the constraints. That means the adjustable range that is forms the constraints.
You have mentioned for upstream discharge and some of the parameters. You have given some range of values in optimization problem. On what basis you have fixed this range?
The range?
Discharge will be ranging from this range. How we have fixed this?
Some of the
optimization
yes, I have referred to some journals, and I have adopted major range from the journals. That means literature. And in some constraints, the range is not available in any of the journal. So I have done this model several times, and I have adopted a suitable value of range where we will have a minimum of this objective function.
And one more question that how you have verified this whatever you have computed or the upstream flood hydrograph, how you have verified whether it is correct or not? So how we have got the
Actually, this is first part of my MTech thesis, and in the second part, using the predicted upstream hydrograph, I am doing flood modeling in HECRAS, and I will get some selected. I have verified the flood extension map with the actual field survey.
Your study, have you having any particular effect on the length or the distance between this particular sections upstream and downstream? Have you considered anything regarding that? Upstream, downstream, yeah.
Sir, I have considered this constant length. I have not, but I have tried several trials with some other lengths. But I cannot say what is the character relationship between the that arises in the objective function when the length is varied.
No, as length varies, or the distance between the sections varies, definitely there will be a difference in the discharge and will be there. So that will be there when you do the normal flood routing. You will have stream flood hydrograph and will depends upon the section that peak discharge etc. will vary. And have you once you arrived at the stream flood hydrograph, you have done the normal flood routing to get the actual hydrograph actually you have for the downstreams? Have you checked it whether it is matching with the actual values? No.
No, sir. No,
so you run these here.
I have not verified with the actual downstream hydrograph, but instead I have verified with the points. That means water surface elevation in selected points only, sir.
Okay. Anyway, you are having a upstream hydrograph with you, so you have done the reverse process and you have obtained the upstream hydrograph. And why didn't you check for the again the process to the downstream graph by normal routing process? Then you could have check it properly. So
Okay.
verified. So
Okay.
other than that, you mentioned that you have verified this. How it is verified? That is a question.
Uh,
Yeah,
that,
verified. You verified means you don't have any data on the upstream side. How you verify
no, sir. This genetic algorithm
that?
itself, this mean reducing the mean absolute error itself forms the verification for the reverse routing process within the
No, no,
limitation
I am
of
asking about how you verified. How you verified it will be like that.
uh,
Without having any observation, how will you verify it? This kind of things? You are having a data on the downstream side. So why didn't you check with the downstream?
okay, okay, sir.
Again, once you get the upstream hydrograph, and why didn't you go for the flood routing with all the governing equations you have? Either you can go for hydrologic routing or hydraulic routing, and you go. So in this case, you have not according any kind of governing equations in GA.
No, sir.
Simply
Only
GA used
continuity
only
equation, sir.
law.
Oh, yes, sir. Only continuity equation was used.
Okay. Okay. Any other GA only will work for this kind of situations, or any other optimization process will give
Like
anybody in the literature anything is available?
no. There are some statistical methods available. Bayesian geostatistics using some statistical methods. Some papers are there, and some using some field marking, geodendromorphic marking. Like that, some papers are there, but there is no other papers related to some artificial neural network or fuzzy logic. Sir.
Okay. In the literature itself, a summary you mentioned that little attention to this kind of area. And other than this artificial intelligence, any other technique for this extreme distribution?
Yes, sir.
Sorry, was
Statistics. Some statistical
any
methods.
other method? What is the problem with these methods, statistical? Why
No,
don't you
sir.
try with the statistical and calculator?
No, sir. Statistic. That means I have not tried with the statistical because I think statistical method that involves more complexity in calculations, and I have not tried with that. But I think the
Okay.
statistical method also is it's also a good paper. That's also a good paper
Okay.
to.
By doing with one technique on optimization technique GA, you cannot verify that. At least you should have done with some other technique, and you could have compare it. If it was variation was very less, you can say that it's okay. Combinations are almost okay. Other than that, how can you verify? That is one of the major question I was asking. Okay. Thank you, sir.
Jasmine,
Sajikumar, sir. Okay.
one thing I would like to know whether you have verified it with any other method or only GA is there.
Only GA method, sir.
Okay. Another thing, you mentioned about objective function. It is continuity equation. How do you say that it is continuity equation?
No, sir. Objective function is not continuity equation. It's just only mean absolute error, computation of mean absolute error.
But in your slide, you mentioned it. It seems like that. Okay, anyway, other thing, what is the purpose of using mutation in genetic algorithm?
That means every time for the creation of better offspring.
No, that's a mutation. I am not asking about the procedure. I am asking about the purpose of using mutation.
That means for every time we have to update these values of parameters. So for that, if one range of parameters in that the range is a vast range, and we have to shorten this range every time this mutation process is carried out, and
Have you come across any situation in which local minima or it is, I mean, stuck in the local minima?
No, sir. No, sir. In Evolver, I think that it may be I have used Evolver. That might be the reason I have not come across such problems.
And you are shown two graphs,
Yes.
on the left side and right side. What are they, the two graphs? Because it was not, I mean, suddenly
First,
moved up.
okay, sir. First graph is it is the graph showing the downstream observed discharge and downstream computer discharge, and we can see two of these lines sync well. That means the error is minimal. And the second one, it is the upstream hydrograph and the downstream hydrograph.
But you said that you haven't verified the downstream hydrograph.
Downstream hydrograph observed, sir. Observed.
No, you said that you haven't verified with the downstream hydrograph.
No, sir. Within the system, it is verified. But I have not done any other Muskingum routing or some other routing methods to verify. That's all.
But have you not checked while doing the HECRAS? You haven't checked the downstream hydrograph.
Downstream hydrograph I have checked, but I have not. I have. That means it comes to the.
You have done the HECRAS later.
Yes,
so have you checked that? Checked it.
Yes, sir. I have checked the downstream hydrograph with this. Then the shapes comes to that, but there are some slight variation. I think it may be HECRAS uses these hydraulic governing equations, and there may be some due to this equation.
Okay then.
Okay.
Any question from the audience? If there is no more questions, and sir, shall we wind up by making some comments? Professor Shibu?
Okay, sir. Okay, sir.
Shall we make some comments?
Concluding remarks.
Okay.
Concluding remarks by you and me, both.
Okay, sir. Okay. Shall I first? Yeah, the presentations, presentations are of good quality, and only thing is that as in the practical considerations, when you see, so whether flood management, the results of that analysis, how could be used for the real management techniques, you are not mentioning many of these papers, and other than that, the